Okay, these are solving some more advanced composite functions. We have two functions, f of x equals 2x plus 5, g of x equals x to the power of 2 minus 3x plus 2. Now what this means is you have negative 2 times g of x plus f of x. So the operation's a plus, so I'm going to line up my parentheses with the addition sign. So in the g, you put the g first, so you put x to the power of 2 minus 3x plus 2. And f of x, 2x plus 5. Now with this negative 2, I apply that in front of the g function. And then I go about my business of simplifying. Okay, so what I'm going to do first, the power's inside, so I don't need to worry about that yet. Okay, now I do need to distribute the negative 2 to everything in here. Okay, but when you distribute, you want to keep negative 2 times 1x squared is negative 2x squared. Negative 2 times negative 3 is positive 6x. Negative 2 times 2 is negative 4. Now we want to put that in a parentheses still because we still have to add the function 2x plus 5, which I just combined like terms. Okay, so x second, negative 2. 6x plus 2x is 8x. Negative 4 plus 5 is 1, and that's the answer. I didn't give you a number to substitute. Okay, next one's a minus, okay, so it's the f minus the g. We will apply that 2 in front of the g function, okay, so I put a 2 there. So f is going to be 2x plus 5, and g is x squared minus 3x plus 2. Okay, it's pretty much kind of the same process as the last one. The power's in the inside. Okay, we do need to distribute this 2. I like to distribute that as a negative 2. Okay, then I can just make that plus negative. So I've got my 2x plus 5, that has no distribution, plus, and then we got negative 2x to the second plus 6x plus negative 4. Put that in parentheses, now I collect like terms. So x second, we have negative 2. For x, we have 2 plus 6, which is 8. And then we have 5 plus negative 4, which is 1. Okay. And it ended up the same as the last one. That wasn't by, that was just a dumb thing that happened. Okay. Okay, now division's easy. So you got fx, so you got your f, 2x plus 5. Now I will need to put that in a parentheses because I do need to multiply that by 5. Okay. Now here we got x to the second minus 3x plus 2. I don't have anything to multiply, so I'm going to leave that outside. You just need to distribute that 5, and it becomes 10x plus 25. And then the bottom remains the same. Divisions are fairly easy. You might have to distribute from time to time. Okay, another plus. This time we have to apply a coefficient of 4 there and a coefficient of 2 here. Okay, so f is 2x plus 5, and g is x to the second minus 3x plus 2. Okay, so 1, 2, 3. Okay, your power belongs to just cx. We do have to distribute, so it's going to be 8x plus 20. Plus, and I have to distribute here, and that's going to be 2x squared minus 6x plus 4. And now I collect like terms. So x second, we have 2. 8 plus negative 6 is 2. 20 plus 4 is 24. Okay, now this is one you haven't seen. This time the circle's closed, so it's not the insert, okay? It's not the input. Okay, what it is a multiplication, okay? So I apply that negative 3 here, and f of x is 2x plus 5, and g of x is x to the power 2 minus 3x plus 2. Now you're going to set up the 1, the 2, and the 3. You don't have to worry about the exponent because it's inside the parentheses. So we distribute, and that's negative 6x plus negative 15 times x second minus 3x plus 2. Now, you don't just do the like terms now because it's not a plus sign in between them. Instead, it's multiplication. So you need to start foiling, okay? This is a long FOIL because you have to distribute the negative 6x, okay? I just distributed that in 3 places. So negative 6x, negative 6x, negative 6x times 1x squared times negative 3x times 2. But then I'll have to also distribute my negative 15. So it's a 2 by 3 distribution. Then you figure out your products. So you have negative 6. X times x squared is x to the third. Positive 18. X times x is x second. Negative 12x. Negative 15x to the second. Positive 15x, and negative 30. Now you can collect your like terms, but you have x to the third as your highest. So there's going to be an x third, an x second, an x, and a constant. So x third is negative 6. X squared, 18, negative 15 makes 3. X, negative 12 plus 15 is 3. And negative 30 last. Okay, so that's a little bit longer. When you have the multiplication, okay, a closed dot, you don't line up the like terms. Well, you will, but you have to do the FOIL, okay? Okay, I'll run through another set, okay? So remember, that's a negative 2 coefficient and a 3 coefficient. So I have plus, so I line up the plus. Pluses are kind of easy. Fx is 3x plus 2. Gx is x squared minus 4x minus 12. And I apply a negative 2 here and a 3 here. Don't forget about that. Because I don't have to worry about the second power because it's inside, but I do need to distribute. So negative 2 times 3x is negative 6x plus negative 4. Plus, and I have to find this product, 3x squared minus 12x minus 36. Okay, now it's just a plus, so you don't have to do any FOIL, okay? X squared your highest, you have 3. X, you have negative 6, negative 12, that makes negative 18. Negative 4, negative 36 is negative 40. Okay, next problem, you have a subtraction. And by the way, if you have a negative, that's a multiplier of negative 1. So this function is the f function is multiplied by negative 1. The g function is multiplied by 2. It's going to be a negative 2 here in a bit. So the f is 3x plus 2, and the g is x squared minus 4x minus 12. So the power is to just see x, and then you can distribute. Gives you negative 3x plus negative 2. Now make that a plus negative 2, so now you can write a plus and then just distribute negative 2. It's going to be negative 2x squared plus 8x plus 24. That's what you get when you multiply. Okay, now yet with the plus you can just combine like terms. So x second, you have negative 2, x, negative 3 plus 8 is 5, and then negative 2 plus 24 is 22. Okay, now in the quotient problem, you apply a 3 and a 2. So the f function's on top, 3x plus 2, and the g function is x squared minus 4x minus 12. Now, all you have to do now is distribute. So that's 9x plus 6, and then here that's going to be 2x squared minus 8x minus 24. Okay, and then that's all further you can go with what your knowledge of how those work. Okay, another subtraction. So I apply a 6 and a 2 as coefficients, okay. So the g function is 3x plus 2. And the f function is x squared minus 4x minus 12. Okay, so 1, 2, 3. The power is to just see x, so I distribute here, and I end up with 18x plus 12. Plus negative, and I distribute negative 2. So that's going to be negative 2x squared plus 8x plus 12. And now with the plus, I just go combine like terms. X second is your highest. So x second's negative 2, 18 plus 8 is 26, and 12 plus 12 is 24. Okay, and then we have our multiplication. So first I line up my functions. It's a times. So the f function has a multi-coefficient of negative 2. The g function has a 2. So the f is going to be, again, 3x plus 2, and the g is x squared minus 4x minus 12. So you don't worry about step 1 on any of these. You just distribute first. Negative 6x plus negative 4 times 2x to the second minus 8x minus 24. Now it's times, so you can't line up your terms yet. You have to do the FOIL, okay? But it's a long FOIL. First you distribute negative 6. So we got negative 6x 3 times distributed. We got to times it by 2x squared. We got to times it by negative 8x and by negative 24. But then we have to distribute the negative 4. So it's like a 6-term FOIL. It wouldn't be really the FOIL. FOIL's 4 products, but you can think of it in that way. So 2x squared, negative 8x, negative 24. So it's going to be negative 12, and x times x squared is x cubed. Negative 8, 6 times negative 8 is 48. X times x squared. Negative 6 times negative 24 is going to be positive 144 with x. You're going to have negative 8 with x to the second. Positive 32 with just x. And negative 4 times negative 24 is 96. Now you can line them up, but x third would be your degree of the polynomial. So x cubed, we have negative 12. X squared, 48 plus negative 8 is 40. X, 144 plus 32 is going to be 176, and then 96. Okay, you can pause the video, do the 5 problems off of these functions here. Okay, now the other thing you're going to think this is even probably more pointless than the other one. Okay, they do it in trig, so that's why I'm kind of teaching it. Graph the function's inverse. Is the inverse a function? Okay, and you got to identify the domain and range. Now, here's what you do to graph an inverse. First off, f of x means y. And no, you're not going to switch the x and the y like you did in the last assignment, not when you have to graph. Here's what you're going to do. If your x is to the second power, that's going to be a quadratic equation. It's a parabola, okay? Parabola, you need 3 points. Those are the U shapes. So parabola means it's a U shape. Sometimes it goes upside down. So the middle's the vertex, and then you got the 2 side points. To find the middle, very easy with these. It's in vertex form. That means I just set x plus 3 equals 0, and the middle x is just the opposite of plus 3, which is negative 3. Then negative 2, negative 4. Now we can just plug those in to the calculator. The answers are going to be 2, 1, 2. But you're not graphing that function, you're graphing its inverse. So what you're going to do is go off the side, make the 3 parentheses, and just do 2, negative 2. You just flip the order with the x and y. 1, negative 3, 2, negative 4. So that's what I'm graphing. So write 2 down 2. Write 1 down 1, 2, 3. Write 2 down 1, 2, 3, 4. Now, so you have a sideways parabola. Now to do the domain and range, you need to label the point in the middle, the vertex, okay? Because that's where your domain and range is based. That's 1, negative 3. So 1, negative 3. Then I do what I do. I make the vertical line, and all points are to the right, so greater than or equal to. But when I make the horizontal line, I've got points above and points below. So that means you ditch the negative 3 and just write y equals all. That means every y coordinate the graph will pass through when it's above and below. Now, here's how you determine whether it's a function or not. Okay? You're going to take your pencil and make what's called the vertical line test. How many times did that vertical line cross my parabola? It crossed twice. When it crosses more than once, it's not a function. Okay? So not a function. It has to cross more than once, not a function. Vertical line test. Okay, now this one here, fx, that means y. We have the radical. It's called a radical function. Okay? Parabolas, we need the 3 coordinates. Radical functions, we make the table. We can't put negatives in the radical because it's a square root. So we go 0, 1, 4, 9 because those are perfect squares. So the square root of 9 is 3. The square root of 4 is 2. The square root of 1 is 1. The square root of 0 is 0. Okay, now at that point, you need to do your transformations. So inside the radical, we got a plus 1, so we have to invert that operation to my x's. So 8 minus 1, 3, 0, negative 1. Now outside, you got a 2, so you have to times 2. So it's going to be 6, 4, 2, and 0. Now to graph the inverse, you just make your table and just invert the points. So 6, 8 now, 4, 3, 2, 0, and 0, negative 1. Okay, so I plot that point first. That's the point I label because that's the last point you can do without having a negative. 2, 0, 4, 3, and 6, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here we go. Because on a parabola, that's the point the domain's based off of. On a radical function, this is the point the domain's based off of. So 0, negative 1. So make a dash vertical line. All points are to the right, so greater than or equal. Horizontal. All points are above it, so greater than or equal. Okay, it's not above and below because you only have the graph with the points above it. Now, this little graph I drew, make a vertical line through it. How many times did that cross the little graph I made? It just crossed once. When it crosses once, it's a function. More than once is not a function. Once is a function. Okay, then the last one's a quick one. Okay, y equals 2x plus 3. You don't have, x isn't to a power, it's not in a radical, this is a linear equation. Okay, with linear equations, set up just 2 coordinates and pick any 2 points for x. I'll go 2, 4. So 2 times 2 is 2, plus 3 is 7. 2 times 4 is 8, plus 3 is 11. But the inverse means you have to flip the points. So 7, 2, and 11, 4. Okay? Actually, hold on. I don't want 11's off the graph. Okay? Just go 0 and 1. Okay? So 2 times 0 is 0, plus 3 is 3. 2 times 1 is 2, plus 3 is 5. So, because I don't want to be off the graph. So 3, 0, and 5, 1. So 1, 2, 3. And then 5, 1, 1, 2, 3, 4, 5, up 1. And that's just a line, okay? So just make a line. I'm not going to make you get a ruler. Well, line, the domain and range are all, okay? Because you don't have a cutoff. It goes forever. So the domain's all, the range is all, okay? You could put x equals and y equals, but that's okay. Now, is it a function? Well, I pick somewhere. It can be anywhere. Make a vertical line. How many times did that cross our graph? Once. So that's a function. Okay, then I'll go over another repeat. X raised to the second power results in a parabola. Those are used. We need 3 coordinates. Remember that fx means y. So in vertex form, x minus 4 equals 0. You can add 4 to both sides and you get 4. So 4 is the vertex x. Then I go up 1 and down 1. I plug those into a calculator and here's what I get. -5, -3, -5. Now, it's the inverse of the function, so you have to reorder it, okay? Much easier than having to rewrite that, switch the x and y, get the y by itself. You just take the coordinates of the regular function and invert them. So -5, 5, -3, 4, -5, 3. And away we go. So -2, 3, 4, 5, 1, 2, 3, 4, 5. -3, 4. And -5, 3. It's a sideways parabola. And the domain range is based off the vertex point, -3, 4. So -3 is the x, 4 is the y. So the x, I make that dashed vertical line, all points are to the left, so that would be less than or equal. If I make the horizontal line, you have points above and below, so I ditch the 4 and write equals all. Now, do we have a function or not? Well, make a vertical line. It crosses in 2 places. If it crosses in 2 places more than once, it's not a function. You just write that on the graph. That's all I want to see. Okay, next one, the y. That's a radical function. Okay, remember, we go off the parent function and it's square roots. I can't have negatives, so I go 0, 1, 4, 9. And then the square root of 9 is 3. The square root of 4 is 2, 1, 0. Now I got to transform it. So inside you got a plus 1, so you need to minus 1. 8, 3, 0, -1. Outside you have a multiplier of -3. So -9, -8. Or sorry, that was wrong. 2 times, that's -6, -3, and 0. Now you have to invert it, okay? So what? I'm busy, okay? All right, okay, so you got 0, -1. Okay. -3, 0, -6, 3, and -9, 8. Okay. Okay, so 0, -1 is where the domain's based. -3, 0, -6, 3. 1, 2, 3, 4, 5, 6, 1, 2, 3. And then -9, 8. So -9, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the domain range are based off this. So you got 0, -1. All points are to the left, so that's less than or equal. And all points are above, so that's greater than or equal. So you have a limited domain and range for both. Make that vertical line. It crosses in one place. We have a function. Okay, and then the last one, if you don't have x to a power, if you don't have x in a radical, that's a linear, okay? You just need 2 points to make a line, 0 and 1. So a half times 0 plus 4 is 4, -1/2 times 1 plus 4 is 3.5. Now you just go off this side and invert those. So now 0, 1 goes here, and 4, 3.5 goes here. So 4, 0, and 3.5, 1. Okay, and that's just a straight line through there. Now on lines, there's nowhere to mark the domain and range. It's just all and all. And it crosses in one point, so that's a function. Remember, if your vertical line crosses in just one point, that's a function. More than one point's